Good day everyone! Today we are going to talk about the various components of the system unit, which is the main part of a computer. The system unit contains all the essential hardware components that enable your computer to function, such as the motherboard, central processing unit, or the CPU, memory, hard drive, and power supply. These components work together to ensure that your computer runs smoothly and efficiently. So let's dive in and explore each of these components in more detail. Alex po. The system unit. The system unit contains electronic components of the computer used to process data. It is available in a variety of shapes and sizes and is made of metal or plastic and protects the internal electronic components from damages. The system unit is the main component of the desktop computer that houses its internal part. It is a box-shaped case that contains important components such as the motherboard, CPU, RAM, hard drive, power supply, and other necessary components. The system unit purpose is to provide central communication between all the hardware components and software that make computer work. Masasabi natin ito yung utak at puso ng computer na kung saan nangyayari ang lahat ng mahalagang function. Kung wala ito, maaaring hindi gumana ng maayos ang isang desktop computer. Next po. Next. Motherboard. The motherboard is the main circuit board of a computer. It's like the nervous system of the computer because it connects all the parts together such as the CPU, RAM, and other components. The motherboard allows everything to communicate with each other and work together to make the computer function properly. It also contains important ports for connecting devices like your keyboard, mouse, and monitor to your computer. Memory chips are installed on memory cards or modules that fit in a slot on the motherboard. Processor. CPU or Central Processing Unit interprets and carries out the basic instruction that operate a computer. The processor or the CPU is the brain of the computer located on the motherboard. It is responsible for executing instruction and managing the overall performance of the computer. The processor significantly impacts overall computing power and manages set of computer operation. The processor is made up of million transistors that work together to process data and perform calculation at incredible speed. Processors can have one or multiple cores which allow them to perform multiple tasks at once. Next po. Microprocessor. On a personal computer, all functions of the processor usually are on a single chip. Next po. Microprocessor has multi-core processor, which means two or more separate processor cores. The other one is the dual-core processor. It is a chip that contains two separate processor cores. Next is the quad-core processor. It is a chip that four separate processor cores. So, some computer and chip manufacturer use the term microprocessor to refer to a personal computer processor chip. It is responsible for executing program instruction, performing arithmetic and logic operation, and managing the overall performance of the computer. The microprocessor is often referred to as the most important component of a computer, as it played a critical role in determining the speed and efficiency of the system. To continue the discussion about the components of the system unit, may alcohol Miss Kinmay.
So next is the control unit. So what is the control unit? The control unit is a component of the processor that directs and coordinates most of the operations in the computer. The control unit has a role much like a traffic cop. It interprets each instruction issued by a program and then initiates the appropriate action for to carry out the instruction. The types of internal components that the control unit directs include the arithmetic logic unit and buses, which will be discussed further in this presentation. The arithmetic logic unit is another component of the processor that performs arithmetic, comparison, and other operations. Arithmetic operations include basic calculations such as addition, subtraction, multiplication, and division. Comparison operations involve comparing one data item with another to determine whether the first item is greater than, equal to, or less than the other item. Depending on the result of the comparison, the different actions may occur. Next is the machine cycle. For every instruction, a processor repeats a set of four basic operations, which is the machine cycle. So this figure you see is an illustration of the machine cycle. For an instance, a student enters a math problem into the memory of a computer. First step of the machine cycle, the control unit fetches the math problem's instructions and data from memory. Step 2, the control unit decodes the math problem's instructions and sends the instructions and data to the ALU. Step 3, the arithmetic logic unit performs calculations on the data. Last step is the step 4. The results of the math problem are stored in memory, and then it appears and on the screen of the student's monitor. So to repeat, the machine cycle is fetching, decoding, executing, and lastly, storing. So let's move on to the system clock. So system time is a representation of a computer system perception of time in computer science and computer programming. The passage of the days on the calendar is likewise considered to be time in this sense. So the pace of the system clock is called the clock speed. It is measured by the number of ticks per second. Current personal computer processors have clock speeds in a gigahertz range. So giga is a prefix that stands for billion, and hertz is one cycle per second. So 1 gigahertz is equals to 1 billion ticks of the system clock per second. So a computer that operates 3 gigahertz has 3 billion clock cycles in 1 second. The faster the clock speed, the more instructions the processor can execute per second. The the speed of the system clock is just one factor that influences a computer's performance. Other factors will be discussed further in this presentation. So why do we need to compare processors and computers? So the quick answer is to obtain the most effective and quick system. One of the key elements of a computer system that affects performance is the processor. In actuality, every other component is there to aid the processor's work because each type of processor has strengths and weaknesses of its own. It is crucial to evaluate processors before buying a new system. So the leading manufacturers of personal computer processor chips are Intel and AMD. The manufacturers can identify their processor chips by model name or number. The Intel processors like Pentium or Celeron are packed in a less expensive basic personal computers. And then AMD is the leading manufacturer of Intel-compatible processors. Their design is similar, performs the same function, and can be as powerful but less expensive. So to help consumers evaluate various processors, manufacturers such as Intel and AMD now use a numbering scheme that is more accurate that accurately reflects the processing speed of their chips. Next is the data representation. Data representation is the way that data is processed, stored, and communicated. So most computers are digital and they can only recognize two discrete states which are on and off. So the binary system is a number system that has two unique digits, which is 0 and 1, and they are called bits. So next is the data representation. So data representation is the way the data is processed, stored, and communicated. Most computers are digital and they recognize only two discrete states, which are on and off. So the binary system, which is a number system that yeah, so the binary system is a number system that has two unique digits, 0 and 1, and they are called bits. The bit is a short for binary digit. It is the smallest unit of data the computer can process. 8 bits should be grouped together to be informative, and when that happens, they form a byte. So now the byte provides enough different combinations of ones and zeros to represent 256 individual characters. These characters include numbers, letters, in uppercase or lowercase, punctuation marks, and others. So this chart you see in the slide is the ASCII, or the American Standard Code for Information Interchange. We can see the different combinations of zeros and ones and their equivalent character. Next. And coding scheme makes it possible for humans to interact with digital computer that processes only bits. In this illustration you see on the slide, it shows how the letter is converted to binary form and then back. When you press a key on a keyboard, a chip in the keyboard converts the key's electronic signal into a scan code, and that is sent into the system unit. Then the system unit converts the scan code into the binary form the computer can process and then store it in the memory. When processing is finished, the software converts the byte into a human recognizable number, letter of the alphabet, or a special letter that is displayed on the screen or printed. So next is the memory. The memory is a computing term for a system or device that stores data for immediate use in a computer, computer hardware, or digital electronic devices. The terms memory, primary storage, or main memory are frequently used interchangeably. So the memory consists of electronic components that store instructions waiting to be executed by the processor, the data needed by those instructions, and the results of processing the data. So the memory usually consists of one or more chips on the motherboard or some other circuit board in the computer. So next, the memory stores three basic categories of items. So the first one is the operating system and other system software that controls or maintains the computer and its devices. Second is the application programs that carry out a specific task, such as word processing. And the third being the data processed by the application programs and resulting information. This role of the memory to store both data and programs is known as the stored program concept. Next is the bytes and addressable memory. So earlier we mentioned bytes. The byte is the basic storage unit in the memory. When application program instructions and data are transferred to memory from storage devices, the instructions and data exist as bytes. Each byte resides temporarily in a location in memory that has an address. An address simply is a unique number that identifies the location of the byte in memory. So for memory sizes, let me now call on Mr. Kenneth Laxina to further discuss the matter.
We have different memory sizes. First is the bits. The bit is the most basic unit of information in computing and digital communication. Next is bytes. A byte is a unit of data that is 8 binary digits long. A byte is the unit most computer use to represent a character such as a letter, number, or typographic symbol. Each byte can hold a string of bits that need to be used in a larger unit for application purposes. Next is kilobytes. A kilobyte is approximately 1,000 bytes. Next, megabyte. As a measure of computer processor storage and real and virtual memory, a megabyte, also known as MB, is 2 to the 20th power bytes, or approximately a million bytes. Next, gigabyte. A gigabyte, pronounced with two hard Gs, is a unit of data storage capacity that is roughly equivalent to 1 billion bytes. Next, terabyte. A terabyte or TB is a unit of digital data that is equal to about 1 trillion bytes. Next is petabyte. An extremely large unit of digital data. 1 petabyte is equal to 1,000 terabytes. Exabyte. An extraordinarily large unit of digital data. 1 exabyte is equal to 1,000 petabytes or 1 billion gigabytes. Next is zettabyte. The number of bytes is equal to 2 to the 17th power, also expressed as 1 sextillion bytes. 1 zettabyte is approximately equal to 1,000 exabytes or 1 billion terabytes. Lastly is yottabyte. A yottabyte is the largest unit of proof as standard size by the International System of Units. The yottabyte is about 1 septillion bytes. Next is type of memory. First is the volatile. Volatile memory is a type of memory that maintains its data only while the device is powered. If the power is interrupted for any reason, the data is lost. Volatile memory is used extensively in computers, ranging from servers to laptops, as well as in other devices such as printers, LCD displays, routers, cell phones, wearables, and medical equipment. Next is non-volatile. Non-volatile memory or non-volatile storage is type of computer memory that can retain stored information even after power is removed. In contrast, volatile memory needs constant power in order to retain data. Example of non-volatile memory include flash memory, read-only memory or ROM, ferroelectric RAM, most types of magnetic computer storage devices like hard disk drives, floppy disk, and magnetic tape, optical discs, and early computer storage methods such as paper tape and punch cards. RAM. Users typically are referring to RAM when discussing computer memory. RAM or random access memory, also called main memory, consists of memory chips that can be read from and written to by the processor and other devices. The processor interprets and executes a program's instructions while the program is in RAM. During this time, the contents of RAM may change. Most RAM is volatile, which means it loses its contents when the power is removed from the computer. For this reason, you must save any items you may need in the future. Saving is the process of copying items from RAM to a storage device such as a hard disk. In the figure in the right side, you can see the steps on how program instruction transfer in and out of RAM. Next is RAM chips usually reside on a memory module, which is a small circuit board. Memory slots on the motherboard hold memory modules. We have three different kind of RAM. First is the static RAM. SRAM pronounced chips are faster and more reliable than any variation of DRAM. These chips do not have to be re-energized as often as DRAM. Chips thus the term static. Next is dynamic RAM. Chips must be re-energized constantly or they lose their contents. Many variations of DRAM chips exist, most of which are faster than the basic DRAM. Lastly is the magnetoresistive RAM. A newer type of RAM called magnetoresistive RAM or MRAM stores the data using magnetic charges instead of electrical charges. Manufacturers claim that MRAM has a greater storage capacity, consumes less power, and has faster access times than electronic RAM. May I call Miss Eliza to further continue this presentation?
Cache. Most today's computers improve processing time with cache. Two types of cache are memory cache and disk cache. Memory cache helps speed the processes of computers because it stores frequently used data. Most personal computers today have at least two types of cache. L1 cache is built directly in the processor chip. L1 is L1 cache usually has a very small capacity ranging from 8 kilobytes to 128 kilobytes, while L2 cache is slightly slower than L1 cache but has much larger capacity ranging from 64 kilobytes to 16 megabytes. Current processors include advanced transfer cache, a type of L2 cache built directly on the processor chip. Processors that use advanced transfer cache perform at much faster rates than those that do not use it. Personal computers today typically have from 512 kilobytes to 12 megabytes of advanced transfer cache. Cache speeds up processing time because it stores frequently used instructions on data. When the processor needs an instruction or data, it searches memory in this order: L1 cache, then L2 cache, then RAM. With greater delay in processing for each level of memory, it must search. If the instruction or data is not found in memory, then it must search a slower speed storage medium, such as hard disk or optical disk. RAM, read only memory, refers to memory chips storing permanent data and instruction. The data on the most RAM chips cannot be modified, hence the name read only. RAM is a non-volatile, which means its contents are not lost when power is removed from the computer. Flash memory. Flash memory is a type of non-volatile memory that cannot be erased electronically and rewritten. Most computers use flash memory to hold their startup instructions because it allows the computer easily to update its contents. Flash memory chips also store data and programs on many mobile computers and devices, such as smartphones, portable media players, PDAs, printers, digital cameras, automotive devices, digital voice recorders, and pagers. Some portable media players store music on flash memory chips, others store in music tiny hard disk or flash memory cards. Flash memory cards contain flash memory on a removable device and instead of chip. CMOS. Some RAM chips, flash memory chips, and other types of memory chips use complementary metal oxide semiconductor technology because it provides high speeds and consumes little power. CMOS technology uses battery power to retain information even when the power to the computer is off. The flash memory chips that stores a computer's data information often use CMOS technology. Memory access times. Access time is the amount of time it takes the processor to read data, instructions, and information from a memory. A computer access time directly affects how fast computer process data. Access data in a memory can be more than 200,000 times faster than accessing data on the hard disk because the mechanical motion of hard disk. Today's manufacturers use a variety of terminology into state access time. Some use fraction of a second, which memory occurs a nanoseconds. A nanoseconds is a 1 billion of a second. A nanosecond is extremely fast. Other manufacturers access time in megahertz, or example 800 megahertz RAM. While access times of a memory greatly affect overall computer performance, manufacturers and retailers usually list a computer's memory in terms of its size, not its time. 10 million operation in equals one blink. It takes about one tenth of a second to blink your eye, which is equivalent of 1 million nanoseconds. In the time it takes to blink your eye, a computer can perform some operations 10 million times. The next topic will be discussed by Ms. Gwen Baitamo.
Removable flash memory. Removable flash memory includes these devices: memory cards, USB flash drives, and PC cards or express card modules. A memory card is a removable flash memory device, usually no bigger than 1.5 in height or width, that you can insert and remove from a slot in a personal computer, game console, mobile device or card reader or writer. Many mobile and consumer devices such as smartphones, digital cameras, and portable media players use memory cards. Some printers and computers have built-in card readers or writers or slots that read flash memory cards. In addition, you can purchase an external card reader or writer that attaches to any computer. Next, a USB flash drive is a flash memory storage device that plugs in a USB port on a computer or mobile device. It is also known as a USB stick. USB thumb drive or pen drive is a plug-and-play portable storage device that uses flash memory and is lightweight enough to attach to a keychain. Many desktop computers, traditional notebook computers, and tablet PCs have a PC card slot or an express card slot, which is a special type of expansion slot that holds a PC card or an express card module respectively. A PC card is a thin, credit card size removable flash memory device that primarily is used today to enable traditional notebook computers and tablet PCs to access the internet wirelessly, while an express card module, which can be used as a removable flash memory drive, is about one half the size of a PC card and adds memory, communications, multimedia, and security capabilities to computers. Ports and connectors. A port is the point at which a peripheral attaches to or communicates with a system unit so that the peripheral can send data to or receive information from the computer. An external device such as a keyboard, monitor, printer, mouse, and microphone often attaches by a cable to a port on the system unit. Instead of port, the term jack sometimes is used to identify audio and video ports. The front and back of the system unit on a desktop personal computer contain many ports. On notebook computers, including notebooks and tablet PCs, the ports are on the back, front, and or sides. Next, USB ports. A USB port, short for Universal Serial Bus Port, can connect up to 127 different peripherals together with a single connector. Devices that connect to a USB port include the following: mouse, printer, digital camera, scanner, speakers, portable media player, optical disk drive, smartphone, PDA, game console, and removable hard disk. Personal computers typically have 6 to 8 ports on the front and or the back of the system units. USB ports allow USB devices to be connected to each other with and transfer digital data over USB cables. They can also supply electric power across the cable to devices that need it. Next, firewire port is similar to a USB port in that it can connect multiple types of devices that require faster data transmission speeds, such as digital video cameras, digital VCRs, color printers, scanners, digital cameras, and DVD drivers to a single connector. Firewire is a high-speed computer data transfer interface that was used to connect personal computers, audio and video devices, and other professional and consumer electronics. Other ports. Some ports not included in typical computers but sometimes used are Bluetooth, SCSI, eSATA, IRDA, and MIDI. For a computer to have these ports, you often must customize the computer purchase order. So let's start with Bluetooth port. Bluetooth technology uses radio waves to transmit data between two devices. Bluetooth devices have to be within about 33 feet of each other. Many computers, peripherals, smartphones, PDAs, cars, and other consumer electronics are Bluetooth enabled, which means they contain a small chip that allows them to communicate with other Bluetooth enabled computers and devices. So it is basically a telecommunication port that allows wireless connection and exchange of data over a short range wireless connection. Moreover, it is possible in mobiles, computers, and other digital devices too. Next, SCSI port. A special high-speed parallel port called a SCSI port allows you to attach SCSI peripherals such as disk drives and printers. SAS or serial attached SCSI is a newer type of SCSI that transmits at much faster speeds than parallel SCSI. Some computers include a SCSI port, others have a slot that supports a SCSI card. SCSI or Small Computer Systems Interface is a technology designed to connect smaller devices to a computer. Next, eSATA port. An eSATA port or external SATA port allows you to connect a high-speed external SATA serial advanced technology attachment hard disk to a computer. External SATA is an industry standard for controlling the various hardware used to connect external storage devices. It competes with some FireWire and USB standards to provide faster data transfer speeds between hardware devices. Next, ear port. Some devices can transmit data via infrared waves. For these wireless devices to transmit signals to a computer, both the computer and the device must have an ear port. To ensure nothing obstructs the path of the infrared light wave, you must align the ear port on the device with the ear port on the computer, similarly to the way you operate a television remote control. Devices that use ear ports include a smartphone, PDA, keyboard, mouse, and printer. The infrared transmitter emits infrared light to activate the infrared receiver, which interprets the data by the transmitter. But first, the infrared data must be encoded in the form of infrared pulses. This means that the devices can communicate with each other using infrared light or radio waves. Next is MIDI port, a special type of port that connects the system unit to a musical instrument, such as an electronic keyboard, is called a MIDI port, short for Musical Instrument Digital Interface. MIDI is the electronic music industry standard that defines how devices such as sound cards and synthesizers represent sounds electronically. It is important to realize that MIDI doesn't contain any actual sound itself. It is simply the instructions for how other instruments should create sound. In this sense, it works like the conductor of an orchestra. The conductor doesn't make any sound by themselves, but they send signals to all of the other members of the orchestra that tell them what to play, when to play, and what expression to use while playing. MIDI is like an electronic version of that. So let's go to the next topic with Miss Rosemary Ray.
So next slide, please. Another component of the system unit are the port replicators and docking stations. So a port replicator is an external device
that provides connections to peripherals through ports built into the device. The mobile user accesses peripherals by connecting the port replicator to a USB port or special port on the mobile computer. A docking station, as you can see the figure on the right side, is similar to a port replicator, but it has more functionality. A docking station, which is an external device that attaches to a mobile computer or device, contains a power connection and provides connections to peripherals. It usually also includes slots for memory cards, optical disk drives, and other devices. With a mobile computer or device in the docking station, users can work with a full-size keyboard, a mouse, and other desktop peripherals from their traditional notebook computer, netbook, or tablet PC. Next component, next slide please. Buses. A computer processes and stores data as a series of electronic bits. These bits transfer internally within the circuitry of the computer along electrical channels. Each channel, called a bus, allows the various devices both inside and attached to the system unit to communicate with each other. Just as vehicles travel on a highway to move from one destination to another, bits travel on a bus. Buses are used to transfer bits from input devices to memory, from memory to the processor, from the processor to memory, and from memory to output or storage devices. Buses consist of two parts, a data bus and an address bus. The data bus is used to transfer actual data, and the address bus is used to transfer information about where the data should reside in memory. Next slide, please. Every bus also has a clock speed. Just like the processor, manufacturers state the clock speed of a bus in hertz. Recall that 1 megahertz is equal to 1 million ticks per second. Today's processor have a bus clock speed of 400, 533, 667, 800, 1066, 1333, or 1600 megahertz. The higher the bus clock speed, the faster the transmission of data, which results in programs running faster. So a computer has three basic types of buses: a system bus, possibly a backside bus, and an expansion bus. A system bus, also called the frontside bus or FSB, is part of the motherboard and connects the processor to main memory. So when a computer professionals use the term bus by itself, they usually are referring to the system bus. Next component are the base. So after you purchase a desktop or notebook computer, you may want to install an additional storage device such as a disk drive in the system unit. So a bay is an opening inside the system unit in which you can install additional equipment. A bay is different from a slot on the motherboard, which is used for the installation of adapter cards. A drive bay is a rectangular opening that typically holds disk drives. Other bays house cards readers and widely used ports such as USB, firewire, and audio ports. So drive bays are most commonly used to store disk drives, although they can also be used for front-end USB ports, card readers, fans, fan controllers, RAID controllers, tool storage, and other uses. So the next component will be the next and the last component is the power supply. So the power supply is the component of the system unit that converts the wall outlet AC power into DC power. Many personal computers plug in standard wall outlets, which supply an alternating current or AC of 115 to 120 volts. This type of power is unsuitable for use with a computer, which requires a direct current or DC ranging from 5 to more than 15 volts. Built into the power supply is a fan that keeps the power supply cool. Some have variable speed fans that change speed or stop running. The depending on temperature in the system unit. Next, so putting it all together. So when you purchase a computer, it is important to understand how the components of the system unit work. Many components of the system unit influence the speed and power of a computer. These include the type of processor, the clock speed of the processor, the amount of RAM, bus width, and the clock speed of the bus. The configuration you require depends on your intended use. Lastly, keeping your computer or mobile device clean. So over time, the system unit collects dust even in a clean environment. So built up dust can block airflow in a computer or mobile device, which can cause it to overheat or corrode or even stop working. So by cleaning your computer or mobile device once or twice a year, you can help extend its life. The preventive maintenance requires a few basic products. So first one is a can of compressed air. It removes dust and lint from difficult to reach areas, removes sticky liquid spilled on keyboards. Next one is lint-free anti-static wipes and swabs. Third one, screen cleaning solution or 50-50 mix of rubbing alcohol and water. So do not use ammonia-based solutions. Next one is a small computer vacuum, or it is also the small attachments on your house vacuum. Next one is the anti-static wristband. It is to avoid damaging internal components with static electricity. And the last one is the small screwdriver. It may be required to open the case or remove adapter cards. So before cleaning the exterior, the next slide. So for the last one, before cleaning the exterior of a computer or mobile device, turn it off. And if necessary, unplug it from the electrical outlet, remove its battery, and disconnect all cables from the ports, and then use compressed air to blow away dust from any openings on the computer or device case, such as drives, slots, ports, and fan vents. Then use an anti-static wipe to clean the exterior of the case and a cleaning solution on the soft cloth to clean the screen. So that is all for our group. Once again, we are the group 2. Thank you for listening.